research opportunities in marine geology. Please enjoy the webinar and thank you. I send back to Dr. Asep as moderator. Thank you, Pak Asep. Opportunities in marine geology. Please enjoy the webinar and thank you. I send back to Dr. Asep as moderator. Thank you, Pak Asep.
Thank you, Pak Mirzam. So everyone. Please wait. Wait a moment. Thank you, Pak Mirzam. Okay. So we try to make a live in YouTube. Do you still hear my voice? Sorry.
Good, Pak Asep. Very good.
Thank you. Okay, everyone. So let's start. Now we are going to the main session. In this session, we will have 3 presentations from 3 speakers. Each speaker has time about 20 to 30 minutes. So if participants have questions or comment to the ongoing presenter, please write down in the textbook. So in the text box, otherwise direct questions or comment will be open in the discussion session following the 3 speakers. So meanwhile, on the presentation time, could you please mute your microphone? Thank you. Let's start this session by first speaker from Dr. Hansan Park. So currently, Dr. Hansan Park is co-director of Korea-Indonesia Marine Technology Cooperations Research Center, or MTCRC. So Dr. Hansan will present more detail about MTCRC research program and also equipments. So let's start, please. Dr. Hansan, time is yours.
Yep, thank you very much. Introduce me, Pak Asep. Yep, I'm very great to have a chance to introduce MTCRC to many audience in here. And my name is Han Samba, co-director of Korea-Indonesia MTCRC. So presentation is consists of two parts. First one is introducing MTCRC and some activity and instrument. And second part is introduce about bathymetry survey equipment and also geology survey equipment operated by MTCRC. So for introduction MTCRC, also have a 3 main part. So general status and main activity and the main achievement and our future plan. So first, I would like to emphasize that our history is started over than 10 years more with Indonesia and Korea. So there were many cooperative research between many researchers between Korea and Indonesia. But 2011, ITB and KIOST started joint research about Jakarta land subsidence and also coastal flooding. And we continue our cooperative research during several years. And finally, 2018, September, we established MTCRC in Zircon. So we are Intergovernmental Joint Research Center for cooperation in marine science and technology between Korea and Indonesia. And the main governmental ministry is Korea side, the Ministry of Ocean Fishery, and Indonesia side is a coordinating ministry for mining affairs and investments. So, and we also have a conduct agency. So Korea side a KIOST and Indonesia side ITB. So we work together, both country and also with a high #1 institution in each countries. So we have 2 co-directors, Korea side, me, and English side, Yvonne, and a total 16 staff, and also we have 2 more internships. So we have 20 members, including us, and we have 3 main departments. First one is about planning administration, second is research and technology, and third one is education training. And especially we have 2 more operation body that is a joint commission on marine science and technology. It is the very important body to decide the important things between two governments. So main members is consist from two governments, and also we have advisory board. Papa Sapui, former deputy minister of CMMAI, he is chairman of the board, and also Professor Sapan and Professor Dietrich and Professor Widodo and Professor Zainar, also one of the member of this advisory board. And we have three major activity and also additional two activity. So major activity, one of major activity to make a cooperation platform and conduct the joint research and capacity building. And additionally, we also conduct a project, kind of ODA or ICRG project, and we support the local community. So first, cooperation platform, that is to make a good relationship with the two government and also including ministries and institutions and universities and others. So there is so many meetings, and also we have a special session in ISOE and also have several intergovernmental meeting. And we conduct a joint research, major 4 items. That is, the first one is about operation ocean propulsion system. Second is ocean satellite and ocean energy and marine debris. So actually for ocean satellite joint research topic, it is developed to a new project which will be launched next year. And we also conduct a capacity building program. So there is 7 courses, and it's divided to parts. First one is a long-term expert courses. So we can give a degree, master degree or doctor degree. So already 53 students are supported by this master degree program, and also 3 students are studying in Korea for doctoral degree courses, and 1 master degree. And also we have many security training courses. Actually we planned many offline training program, but by COVID-19, so we conducted online program. So we already invited many lecturers from Korea, and also have equipment operation security training program by online. And we also support the local community, kind of Cirebon coastal cleanup campaign. So 200 more people join, and also we gathered 1 ton of marine waste. And I would like to introduce as a major achievement. So I already mentioned before, Ocean Satellite project is developed. The title is establishment of application system for managing Indonesia water using Korea geostation satellite. So to make this project, MTCIC conducted many feasibility study and also meeting with many stakeholders in Indonesia and Korea. And finally, we will start this project next year. And also from Indonesia government official request, we joined the ICRG survey. ICRG is Indonesia Coral Reef Garden, and it is linked with also support Bali people's economic damage by COVID-19. So we survey bathymetry and ocean environment using CTD and also drone. So that is will be used for base data for marine coral reef rehabilitation and replantation. And also we support Sriwijaya SAR activity last earlier this year. So it is a very sad accident for Indonesian people, and we support this activity. Just a request from Indonesian government. And also we conduct the Cirebon local government support by a survey ocean status and also mangrove using equipment and with ITB. And for support to seaweed aquaculture, so we surveyed just last week. We visited Maluku, and Kai Island. So survey CTD with 8 sensors and also drone survey to make a map, and we will continue this also support. So next is about our equipment. We have research boat, 12-meter length, ARA boat, and multi-beam echo sounder, and SBP and drone and RTK DGNSS and CTD and high performance server, and the tube breaker and computer set, floater and software. And this year, we will also we will make an ocean chemistry laboratory with nutrient auto-analyzer and heavy metal auto-analyzer and FTIR spectrometer for microplastic, and ADCP and tide gauge and weather station, and hyperspectral radiometer. And our plan is actually we want to be an international joint research center, but we will be facilitator for 2 government and countries cooperation, and also researchers and educator and support for local government and community. But it is a general target, but we need to some kind of a more strategical approach. So we reviewed Indonesia's maritime issues just related with our activity. So logistics and environmental and fisheries potential will be listed and a major issue in Indonesia. And we reviewed Indonesia marine policy and also CMMA's strategic plan. So we listed up the several items for our future research and activity. So it is based on world issue, climate change and also sustainable. Sustainable is a major word in the world issue, and also we reviewed the national policy and program, and also linked with the related project and the possibility in already existed in MTCIC. So our future topic will be Operation Ocean Focusing System, and also about the marine blue carbon. So we will survey mangrove and seagrass or coral reef continuously, and also we support ocean pollution, including marine debris and smart agriculture. This is a more strategical approach to achieve that goal. That is, we want to be international ocean survey experts first. So we improve our capability for marine survey analysis, and we will provide the data by international standard, and we will support the government. Of course, we will broaden capacity building program and also strengthen cooperation platform. So to improve our capacity for marine survey analysis, we already have many type of equipment. So it is a very good chance to us, and also we want to share this chance with many Indonesian university and students and researchers. And to broaden capacity building, we will have more cooperation with the university. Yeah, so not only in ITB, but also IPB, Kadamajar, and also there is many good university in the area of Indonesia. So we will cooperate and make some kind of a more program, including this listed of the courses. And also we will strengthen cooperation platform with the government, with also KRK and KKP and the other ministry and agency and institution. Yeah, we know many agencies becomes a brain, but also we also need to more cooperation with them and university. So that is next. I will move to marine geology survey equipment. So this is about the marine. That is, we have bathymetry survey equipment and also strata exploration equipment operated by MTCIC. So about that, there is a 2 parts. One is a submarine topography, and next one is geophysical exploration (SPP). So first, submarine topography. Multi-beam echo sounder is a device that measures the water depths and by accurately information reflected on the seafloor by generating multiple sounding. Many beams are arranged at a wide angle, about 160 degrees under the boat to measure the submarine topography with a wide width as and at the same time the geological property of the surface layer of the seafloor are distinguished using the reception intensive information of the beam that reaches the seafloor and is reflected. So mud and sand and rock, artificial something. We can classify by using this reflected intensity information. The submarine topography map on the left side of this slide is result of a survey in Tonga. Due to the wide angle of multi-beam echo sound, it was measured to the low depth, very shallow depths of the sea. Usually that is not easy to survey, but this multi-beam echo sound can reach very shallow water, so we can get the very high resolution bathymetry information. And this data will be used for basic information to survey, to research about seabed and also oceanography, and also for navigation safety. And the right side, the Seabed Imagery, that is a black and white map, this is about the sea surface classification obtained this multi-beam echo sound, and I already mentioned that used for reflected strength of the signal. So it is used to analyze the topographic properties such as reef marks and the type of sea surface sediment that are difficult to analyze due to small and difference in the water depth. And the multi-beam echo sound operated by empty shells is a geoswas 4R that can occur the very high resolution data within 100 meters of depth. The beam measurement method is interferometric multi-beam echo sounder using the phase interference method. There are sound wave transmitters and the starboard and the port side, respectively, and consist of motion sensors that measure the behavior of a boat and some direction of emitted sounding, and two GNSS and surface and water for sea surface sound speed meter and the deck unit. And geoswas has very wide angle of beam, about two times the depth of the water, and is a right weight that can be operated on Zodiac boat, and also that is very easy operated software and analysis and acquisition and post-processing. In particular, it is a very optimized model for operating on the coral beach, such that and very shallow water. The resolution is 3 millimeters, and very high resolution data can be obtained. So I would like to introduce the characteristics of multi-beam echo sound beam forming and interferometry method. Beam forming multi-beam echo sound is a method of measuring a number of physical independent beams, up to 256, and the number of beams does not change. Depends on the depth. But intermetry method is a measurement method derived from the side scan principle. As physically, there are 4 beam transmitters on the port and starboard side, but the infinite number of beam are occurred using the phase difference of the beam being reflected by object. Therefore, the interferometry method can occur the countless amount of depth information without gaps, and can measure the wide angle. Because of the number of these measured beams is different, the resolution of the interferometry multiple echo sound is generally high. If you look on the left side of this slide, and there are the data measured in the same area, and one left one is a beamforming, right one is interferometry. So you can see that interferometry multiple echo sound can measure the more fine terrain differences. The interferometry method has recently developed, and it is the latest method that has been applied, and we also try to use this multiple echo sound and to find out more good things related with the beamforming one. And next one is, I will briefly introduce the exploration of strata using sound. Sound not only pass through the seafloor, but also through the strata. So reflected or reflecting from the discontinuous surface of a strata, which can be occurred to explore the stratum structure. In general, the characteristics are classified according to the frequency of the sound source. And high frequency sound source have low transmittance, but high resolution. And the low frequency sound source have a deep transmittance, but low resolution. Yeah. So SBP and sparkle and airgun are commonly used. Depends on the type of sound source used. And according to each frequency difference, the SBP is used exploration of sedimentary layers of the natural base layer. Sparkle is used for intermetry layer, and the airgun is used for more deeper exploration. Now, recently, with the development of exploration technology and equipment with a wide frequency range has also been utilized. Look at the result of strata exploration on the left side. Left side of slide, SPP is useful for identifying the natural and the deep strata of the airgun. So equipment operated by MTCS is a SPP, which is Kongsberg's the Geo Plus model. It is a side mount method that is mounted on the starboard of our boat, and operation method is very simple. The transmittance is about 30 meter in the sand layer and 80 meter in the mud layer. It has good characteristics to use in Indonesia water, I think. And this equipment is mainly useful for this distinguishing sediment layers. The frequency range is from 2 until 18 kilohertz, and you can select and use Pinger and Ricker and chart mode. So this is a table for comparison each model we considered when we prepared this SPP. It has a comparative advantage in transmittance and frequency format and the weight, and which are most important factor to choose appropriate model for us. And the multi-beam echo sound and SPP operated by MTCSI are optimized model for use in Cirebon and Java C. And also two equipment can operate at the same time. So we hope there is many research and survey with many researchers in Indonesia, and we hope operate well more in the future. Yeah. Thank you very much. Yeah. Thank you for your attention. Yeah. Thank you.
Thank you, Dr. Hansan Park. So everyone, if you have question, please keep in the next session discussion. But if you have a recent question, so you also might write down in the text box, please. So we will discuss after all presenters presenting the topics. Okay, we are going to the next speaker is Dr. Kim Han-jun. So Dr. Kim Han-jun is a scientist from Korea Institute of Ocean Science and Technology. And currently, he is also professor from University of Science and Technology, UST in South Korea. Professor Kim will present about neotectonic of the Eastern Korean margin. So please, Professor Kim, time is yours.
Okay. Thank you, Dr. Sepolo, and good afternoon, ladies and gentlemen. It takes just few seconds to set up my work. Okay. Can you see my presentation?
Yes, clearly.
No problem. Okay. So, good afternoon, ladies and gentlemen. I'm very happy to be part of this meeting. I think you are working very hard on tectonic processes in the Indian Ocean subduction zone. I will give a talk on tectonics of the back-arc region in the Northwestern Pacific subduction zone. My presentation is titled Neotectonics of the Eastern Korean margin in the Northwestern Pacific subduction zone. Like the Indian Ocean subduction zone, the Northwestern Pacific subduction zone is populated by abundant back-arc seas, and the East Seas between the Korean Peninsula and the Japan Arc is one of those seas. The East Sea is comprised of three major deep water sedimentary basins and intervening structural highs. Three major basins are emplaced by back-arc seafloor spreading, and the structural highs are lifted fragments of continental crust. And we can see that the earthquakes offshore the Korean Peninsula occur mostly in lifted continental crust, but extremely rare earthquakes in the region of back-arc or oceanic crust. A global tomography shows, as you expect, that the Pacific plate is subducting under the Japan Arc and goes all the way across the East Sea and extends to the eastern part of China. I will talk about how the Japan Arc was separated from the Korean margin and how the geologic structure evolved at the Korean margin. I will then talk about the correlation of geologic structure with the earthquake occurrence. The separation of the Japan Arc proceeded with back-arc rifting and spreading at the Korean margin from the late Oligocene to the middle Miocene. In particular, during the initial stage of rifting, the southwestern Japan arc was separated eastward from the eastern Korean margin. After breakup, the northern portion of the Japan arc rotated counterclockwise, whereas its southern portion rotated clockwise. Then a breakup of continental crust and the back arc spreading followed. This is the main stage of the arc separation, possibly from the early to middle Miocene. During this stage, the southwestern Japan arc rotated clockwise significantly. This is the slice of a shear wave velocity at the 70-kilometer depth in the East Sea, computed from ambient noise tomography of earthquake data. We can see low velocity anomalies elongated along the Korean and the southwestern Japan arc margins. This indicates that the two margins are conjugate and the southwestern Japan arc rotated clockwise. Around 15 MA, 15 million years ago, the north-moving Philippine sea plate collided with the Japan arc. As a result, the back arc region became subjected to compression. At the southeastern Korean margin, the largest earthquake was a magnitude 5 event that occurred 5 years ago. The magnitude is nothing compared to the earthquakes in and around Indonesia. But anyway, it drew great attention in Korea. The southeast Korean margin is a transition zone where continental crust becomes thin rapidly due to back arc rifting. Therefore, we need to identify faults and the geologic structure to explain the earthquake occurrence. The stress in the back arc changed to east-northeast and west-southwest compression in the Pliocene that created a small anticline trending northwest to southeast here, as you can see. The magnitude 5 earthquake occurred in the northern tip of this small anticline. We can infer the crustal structure in the epicentral area by looking at the shear wave velocity vertical sections. Previously, I interpreted that the upper and lower crustal boundary is represented by the shear wave velocity of 3.6 kilometers per sec, and the Moho depth by shear wave velocity decreasing from 4 to 3.75 kilometers per sec toward the back arc oceanic crust. Therefore, we can see the focal depth of the magnitude 5 earthquake at 16 kilometers is near the upper and the lower crustal boundary. In addition, the crustal thickness decreases rapidly across the margin. So, as is well known, stress is concentrated at the geometric discontinuity and can easily generate earthquakes. A large volume of multi-channel seismic profiles is available that was obtained at the southeastern continental margin. There's also a 3D seismic data cube depicted by the yellow rectangle that includes the epicentral area. With seismic profiles, we can identify faults. We correlated seismic profiles with the existing stratigraphy to determine the ages of the sedimentary sequences. The sequences from the bottom to top represent shallow marine deposition in the lower part, transition to sharp and slope margin, and marine sedimentation. associated with the substance with crustal extension. And on seismic profiles, we could identify abundant faults that make up flower structures here. The magnitude 5 earthquake occurred in flower structure named F1. I interpret the stratigraphic reflectors convex upward are dominant in flower structures. They may represent positive flower structures. This figure shows the traces of faults on the 16 million year boundary. The flower structures consist of the northern and southern segments with different fault orientation. The focal mechanism solution of the magnitude 5 earthquake indicates strike slip that is in good agreement with the northern portion of flower structure. Other earthquakes have almost the same focal mechanism solutions, which indicates that the earthquakes occur on a series of parallel oriented faults. I interpret the reactivation of extensional faults created during back arc rifting are currently reactivated with dextral slip under the current east, northeast, west, or southwest oriented compressional stress field in and around the Korean Peninsula. This figure shows how the sedimentary sequences on seismic profiles have built up at the margin. We can recognize additional growth of the fault or anticline since the Pliocene due to the current compressional stress. This means that the present compression is not from the collision of the Philippine Sea plate. The collision of India with Asia has been considered as the source of the stress field in Northeast Asia because the stress direction at the Korean margin appears to follow the fan-shaped stress field induced by the India-Asia collision. Recent observations from earthquake analysis suggest that the stress in the Korean Peninsula decreases much from east to west. GPS observations in the southwestern Japan arc show an interesting result that the Pacific side of the arc is compressed to the northeast, as expected because the Pacific plate is subducting to the northeast direction. But the back arc side of the arc is compressed to the east or southeast. The far field stress induced from the India-Asia collision is unable to explain the stress field in the back arc side of the Japan arc. Instead, we may think that the stress originates from the back arc. This figure shows the shear wave velocity slices from 120 to 70 kilometer depth at an interval of 10 kilometers. We can see that the mantle of welling with the low shear wave velocity at the Korean margin is advancing toward the Korean Peninsula as they rise. Approximately at the 80 to 70 kilometer depths, the anomalies are elongated along the Korean Peninsula. This seems to suggest the lithosphere and asthenosphere boundary depth around the Korean Peninsula. The p-axis directions determined from earthquake data are perpendicular to the inferred direction of the low velocity anomalies. Small-scale edge-driven convection that develops in the upper mantle beneath the transition of thick cold cratonic lithosphere and thin oceanic lithosphere is a model to drive mantle convection toward the thick and cold lithosphere at the upper boundary of a convection cell. We estimate that the mantle overhang can exert a compressive stress on the thick continental lithosphere of the Korean Peninsula by directing the convective flow toward the peninsula. The length of fault segments at the Korean margin is difficult to measure because the faults are highly bending and large events with aftershocks have not occurred. To me, the straight portion of the faults does not exceed 7 kilometers. In this case, the widely used empirical equations estimated the maximum possible magnitude of earthquakes of 6.1. I also estimated statistically the maximum expected magnitude using HA3, a software by Dr. Kisko that uses earthquake data recorded so far. The estimation suggests that the margin can generate earthquakes with the magnitude less than 6. So I come to conclusions. As we can read the conclusions, the Korean margin includes a transition zone from a lifted continental crust of the Korean Peninsula to back arc oceanic crust underlying deep sedimentary basin. And we can notice that the crustal thickness decreases very rapidly across the margin. And the epicentral area of magnitude 5 earthquake is in the northern tip of an anticline created by the present east-northeast, west-southwest compression that initiated later than 5.5 million years ago. And abundant faults striking north-northeast, south-southwest were identified on seismic reflection profiles in the epicentral area that make up strike slip fault systems. Asthenospheric upwelling recognized in the uppermost mantle and elongated along the continental margin is inferred to induce a significant portion of the present westward compressional stress. The maximum magnitude of earthquakes expected in the epicentral area of the magnitude 5 earthquake is estimated not higher than magnitude 6. Thank you, ladies and gentlemen.
Thank you, Professor Kim. So for your nice presentations regarding the tectonic in Korea, so it's very nice, and also your finding. Is it okay if the discussion we move to the next in the last session? Do you still have time, right?
Yes.
Okay, thank you.
I will stay at my seat until the end of
Thank you for your time, Professor. Okay, let's. We are going to the third speaker. Is Dr. Andri Slamet Subandrio. Dr. Andri Slamet Subandrio is a researcher from Geological Engineering Study Program, Faculty of Earth Sciences and Technology ITB. He has a lot of research related to marine geology in the last decade. He will present his experience in mineral exploration and also the future research prospect in Sunda continental shelf. So, Pak Andri, are you ready? The time is yours.
Thank you very much. So I have a little bit of presentation about the Sunda shelf. So good afternoon, ladies and gentlemen. Good afternoon.
Yes. Good
Mr.
afternoon.
Hansan. Yeah. Okay. I will share screen. Yeah. Okay. Could you see the presentation and big screen? Hello?
Yes, Pak Andri, it's clear.
Okay, you can hear my voice?
Yes, also clear.
Okay, also clear. Okay. Okay. Good afternoon, Dr. Hansan and Dr. Kim Hansen, Dr. Mirzam, Dr. Asep Saifullah, and all of students and also guys from other institution. Yeah. So the afternoon, I will present our experience in the exploration of Indonesian marine geology. as is well known, oil and gas mines in Indonesia are located partly in offshore, such as on the north coast of West Java or East Java. Also, the other also in Mahakam Delta. Yeah. As mineral sources, for example, tin is mined from offshore also. Yeah. For example, in Bangka Belitung, yeah, in the form of tin sand, which dredged from seabed of the Sunda Shelf. Yeah. So we have some cooperation with Germany and also with Australian for marine exploration. And it began in 2000, in year 2000. Yeah. So we have here, for example, here we have here, for example, Bandamin cruise from in the North Flores. Yeah, in the North Flores. Yeah. This is the example for our deep sea or seabed exploration. Yeah, the Comba Flores example, the Comba volcano lies in the northern Flores, and also we have also investigate between Flores coast and the Comba that may be hydrothermal mineralization. Yeah, in the active hydrothermal mineralization in the seabed. So yeah, this is the Barunajaya, the research vessel made in Norwegia that we have for this research vessel in early 2000. So this is the map that show Comba volcano in the northern Flores. Yeah. Yeah, in the northern Flores here. So we expected that between coast of the northern Flores and the sea volcano, maybe they have also active hydrothermal system. So from 2000 until 2010 maybe, we have some exploration in the some region in Indonesia. This is the volcano map of Indonesia. This is the richest volcano in the world, and so maybe we have also some mineralization in the seafloor according to the volcano in the partly of Indonesian. For example, here the first exploration in 2000 is the Bone Gulf. Yeah, the Bone Gulf is carried out with BPPT. Yeah, so we have exploring the seabed in the Bone to searching for placer mineralization, and then we have also Bandamin 1 until Bandamin 3. So we working together with the Free University Berlin to searching hydrothermal active in the seabed of the northern Flores. And we have also co-working with the ISA from CS Aero in Australia, and we searching here also for hydrothermal active in the Una Island or surrounding the Una Island. And then in 2002 we have also Java Trans expedition to searching deep sea mineralization, and we have one here gas hydrate. Yeah, gas hydrate in depth 2,500 meters. Yeah, and this is 100 kilometer from Sukabumi, 100 kilometer from Pelabuhan Ratu Sukabumi. Yeah, and we dive until 2,500 meter with the Shinkai from Japan. we have cooperation with the JAMSTEC, Japan's Marine Technology, and Japan's Science and Marine Technology. So the recent work about the seabed exploration is in the Bangka Belitung. We're searching here for tin sand in the seabed of Bangka Belitung. Yeah, and we have until now PT Timah mining the tin sand from 60 meter, 20 until 60 meter on the seabed, on the Sunda Shelf. So we have also recently the silica sand for high purity quartz and some rare earth mineral exploration in the Riau Islands. So when we look the geological map of Indonesia, the marine mineral is related also to the Sunderland. Yeah, maybe after this we can see how is the Sunderland evolution here. So the ore mineral here can occur in igneous rocks, in metamorphic rock, or sedimentary rock. Yeah. So broadly speaking, in Indonesia there are two metageological provinces. Yeah. Firstly is the associated with the acid magmatism, and secondly associated with the ultrabasic. The acid magmatism produced for recently for example, tin mineralization. Tin, maybe tungsten or niobium tantalum, and mostly in the part of Indonesia. And ultrabasic domain in produce also, for example, nickel laterite, and also maybe placer of chrome, platinum group elements, and also cobalt. Yeah, this is almost the ophiolite complex, mostly in the central Sulawesi, also in eastern Indonesia, mostly. Yeah. So mineralization in Indonesian archipelago is related also to the history of tectonic and magmatism. Yeah, the mineralization primary for tin, wolfram, niobium, tantalum, and uranium, also zircon and monazite, among other, is related to the Permo-Triassic and tectonic magmatism. So that, yeah, this is the very nice map that produced by Professor Katili in 1980, that there is a lot of subduction and also related to magmatism. For example, Bangka Belitung, we have tin deposit that also from Permo-Triassic subduction magmatism. And also we have also, for example, gold and copper mineralization, mostly in the middle until late Miocene. So for nickel and chromite in Celebes and also in the Halmahera, we have with the tertiary magmatism and subduction complex. So we exploring the ocean floor here and determine that we have some special case in the Sunda Shelf. Yeah, for example, Sunda Shelf is when we look this here, Sundaland is also from Thailand, Cambodia, also Malay Peninsula of Malaysia, Sumatra, until West Kalimantan. So Sunda Shelf lies between Sumatra, yeah, Jawa, and also West Kalimantan, also in the southern part of Cambodia, or maybe the eastern part of Malaysia Peninsula. This is the large image of the Sunda Shelf. You can see the Sunda Shelf itself, yeah, is the geology of Sunda Self is mostly related to the Sundaland. Yeah, the Sunda Self and Sundaland were once a unit during the glacial period. Yeah, at this time, the Sunda Self was a giant valley. Yeah, with very wide area that filled by river, and the originate or upstream region is the eastern part of Sumatra, western part of Kalimantan, yeah, and also northern from Java, and also southern part of Cambodia, yeah. And the Sundaland is also, I think, is a big valley that can also some animal, yeah, some paleo animal like elephant can go from Sumatra until Java. We have some fossil, very good fossil from Majalengka, yeah, that indicate that elephant can go from Sumatra to Java, yeah, without the boat, yeah. This is with the foot, yeah. This is the Paleo River of Sundaland, yeah. This is a lot of stream that upstream in western part of eastern part of Sumatra. Also, some is also in from western part of Kalimantan, and also southern part of Cambodia. So the ancient river flowing into the Sunda Self, into the Sunda Self Valley, and have partially transport and deposited valuable minerals such as tin, wolfram, tantalum, niobium, also zircon and monazite, and several types of heavy mineral. Yeah, this heavy mineral deposited in the valley of the river and channel, and it's now become the seabed of the Karimata Strait. Yeah, this is the opportunity that we can explore more in the Sunda Self, yeah, because it's very large valley that maybe have some seabed deposit for mineral. So when we saw the global sea level curve from early Earth, yeah, from 500 years ago, yeah, until now, and so in the recent yeah, in the maybe in the last glacial period, yeah, Sundaland lies in the level of maybe 100 meters from here, yeah. So we have here, for example, the Sundaland in 20 kilo years before present, yeah. We have that sea level was maybe 116 meters below present, because that's Karimata Strait by now. Karimata Strait, yeah, is a big valley, yeah, is a big valley, yeah, here, yeah. So when we compare the sea level at the 20 million years ago, the level is same as the Monas. Yeah, this is the monument in the Madrasah of Jakarta. Yeah, this is also 120 meter. Yeah, it is same with the Monas. Yeah. So in the valley we can find a lot of channel. Yeah, a lot of channel that may be filled by the mineral. Yeah, for example, this. Yeah. So we can also see the Sunda Self is also evolution. Yeah, the evolution of Sundaland has had also impact on the Sunda Self. Yeah, one of it is being placed for heavy mineral enrichment. Yeah, for example, offshore from Bangka and Belitung. This is the Bangka Island. that also rich with the mineralized of granite, yeah, thin mineralized granite. For example, in the Linyu, yeah, also in the Bukit Pemali, yeah, and also Bangka by now have also some exploration on the land, yeah, mainly in the placer deposit, yeah, in Bangka. In offshore is also very intensive, yeah. PT Timah has maybe two or three decades have explored in the offshore area and also mined the thin sand from seabed, yeah, under 20 meters below the surface, yeah. This is one the hypogen primary ore mineralization. So this is the general image that show how is the mineralization can be evolved in the granite intrusion. So if the mountain in the western Sumatra or maybe in the Bangka Belitung, yeah, have also mineralized granite, maybe by the water from the rainwater, also from the river, can also transport it until the beach area, and also the beach area also rich by the minerals. So like this, yeah. If we have, for example, the granite magmatism with the Grayson mineralization, and we have also maybe opportunity the fluvial system that rich with the thin placer until the offshore area. Yeah. For example, here is the thin is the sand from Bangka Belitung that rich on tin and also some monazite and also zircon. So this is the some microscopic image that I have photographed from thin sand or sand in the from Bangka Belitung. That's rich with the and also cassiterite and also some zircon and monazite. Sometimes when we have also lucky, we can also get the some gold nugget, yeah, gold nugget, yeah. For example, in the Kalimantan, in the southern part of Kalimantan. Yeah, okay, this is the some mineral sand. In the left side is the from Bangka Belitung. In the right side is from the ultrabasic area from Celebes. Yeah, this is so that some olivine, also chromite, also magnetite together on the beach sands. This is the zircon, from western part of Kalimantan. This is the placer that maybe by traditional people until now is mined for zircon. I think we can use everything for use for zircon. Yeah, maybe from Jeverly until anti-radiation for the nuclear power plant, we can use the zircon. So the regional area of the Sunda South itself maybe the richest area for the thin granite, and that's why the offshore water between Sumatra and Kalimantan may be rich also by thin sand in the seabed. So this is the Bangka Thin Granite Complex that that is the root, I think. Yeah, this is the root of the granite Bangka, because all of the cupola has been altered to Grayson, and then it's also easy to erode it and also transport it. Yeah, and this why the granite in Bangka or Belitung is not too high. Maybe the highest peak of granite Bangka in Belitung is until 500 meter. Yeah, until 500 meter. And also mostly the Bangka granite, the granite in Bangka is until only 100 meter. Yeah, maximum, because all of the granite is graizenized, and graizenized is easily to eroded and also transported. This is the Greizen. Yeah, this is the Greizen of Bangka that also rich in the thin sand. Yeah. So primarily the granite in Bangka is altered to Greizen, and the Greizen mineralization is also a lot of ore here. Yeah. For example, beryllium, niobium, tantalum. Yeah, lithium also we have here. Yeah, also caesium also that may be mineralized in the Greizen system. This is the Bangka, yeah, Bangka Belitung Island, yeah, Bangka Belitung Islands that show some outcrop that only emerge if low tide. Yeah, if low tide, we can see the island, but in the high tide, almost the island is underwater. So we have here exploration for tin concentrate in the seabed of northern Bangka. We have, for example, here 3 or 5, 4 or 5 kilometers from the beach, and we have some program to mapping the seabed in underwater. Yeah. So this is why we can explore. So this is the Bangka Belitung that shown granite, yeah, granite in the red color. Yeah. So we use we have to explore the Tanjung Penyusup, yeah, in Tanjung Penyusup area. Yeah. This is the granite landscape that also mostly dominated by granite. So this is the way why until now PT Timah Bangka, PT Timah mining in the seafloor, yeah, mining in the offshore, because some of the river is filled in the Karimata Strait. Yeah, yeah, yeah. So this is the bedrock. Yeah, this is bedrock that from a single seismic channel seismic. Yeah, and we have some channel that may be filled by coarse fluvial deposit and also thin sand. So we begin with our survey. This is marine survey that we have done in 2006. Yeah. So we use the traditional fish boat, and is mounted with high-tech equipment. Yeah. For example, GPS and also echo sonder. Yeah, and also single channel seismic. Yeah. So this is the for thin sand exploration on the seabed of Karimata Strait. This is the instrument that we use, yeah, for the exploring seabed. Yeah. For example, we have here also simple echo sonder, also yeah, simple echo sonder, and this is the single channel seismic equipment. Yeah, single channel seismic equipment with also recording equipment. So this is the mounted the beamer, yeah, for beamer that boomer, sorry, boomer that can be used for the seismic. So this is single seismic boomer in action for seafloor at mapping at the Brinyo offshore at Bangka. So this is the pathway of research vessel. Yeah, we use a fish boat also for thin sand exploration on seabed Karimata. Yeah, this is the result. The result is the bathymetry map of Tanjung Penyusup offshore. Yeah, that we can maybe prepare for next exploration. Yeah, to detect the way or channel that may be potential for thin sand. This is the seismic profile yeah, and its interpretation. So we have here some white sediment channel, and the seafloor. This is maybe potential for the heavy mineral concentrate that may be deposited in on the seabed. This is the block diagram seafloor that construction from bathymetry map. It is also clear that some is maybe potential for tin or maybe the heavy mineral deposit. Yeah. Also here is the map of basement of our result from the single channel seismic. So this is the block diagram basement morphology. Yeah, that maybe we can explore some valley that may be filled by heavy mineral sand. Also the basement that under other perfection. So after all, we can use the isopach map. Yeah, the isopach map of sediment thickness is very important because we can know how the thickness of sediment that may be contain thin sand. Yeah, this one. Yeah, this is the 3D diagram that maybe we can prove how the thickness of thin sand in every valley. Yeah, in every valley that in the seabed. Yeah. Okay. So the conclusion is the general paleo-channel orientation for the present is found in the west or east of the Sunda Shelf. Yeah, depth of paleo-channel and thickness of sediment infill research area in the Penyusup offshore is relative increase in the northward. Yeah, so we recommended that validated sediment sampling such as gravity coring, maybe also dredging. Yeah, maybe especially for northern zone, because the northern zone is also we have in deepest valley that may be also thickest of sediment. So the aim of drilling exploration is to prove or identify the presentation of thin bearing sediment associated with the paleo-channel of Tanjung Penyusup offshore. Yeah, this is the result. So this is the mining vessel. Yeah, so I can say maybe mining vessel of PT Timah. They have two big vessel that once dredge the thin sand, and also the other one have processing in the ship, and so we can get directly the thin sand from seabed, and we can throw all of the silica sand back to the sea. Yeah. So the thin belt in granite in Bangka Belitung is very rich in tin. Yeah, and also maybe with the rare earth element, maybe in zircon or monazite. Because the rich of tin, some people also have traditionally equipment. For example, here is the very easy to make. Yeah, the ship, yeah, that can also get the thin sand only from 1 meter. Yeah, 1 meter deep. We can get the thin sand here, because that a lot of people traditionally also mining the thin sand from the shallow offshore. Yeah. So another another prospect in the Rio Island is also high purity quartz. Yeah, high purity quartz is also very usable, yeah, for all industry. For example, for semiconductor, for solar cell, also for glass industry, for ceramic, yeah, and also, yeah. This is the high purity quartz sands that located in Singkap area, in Singkap Island. Yeah, this is so some of the quartz mining is have a stockpile here. Yeah, for example. So we can go here in the southern part of Singapore. Yeah, southern part of Singapore, southern part of Batam, maybe atau southern part of Pulau Bintan. There is maybe 100, yeah, maybe 100 of island, small and big island in the southern in the Rio Island. Rio Islands is the province, yeah, is province, is Provinsi Kepulauan Riau or Rio Islands province. Yeah, so this is the red sandstone that have some resedimented sand for high purity quartz. Yeah, this is red sandstone that lies in the Singkap area and also in the Lingga area. Yeah, this is the topography of some island in the Rio Islands. Yeah, this is the Sebangka that have some anticlinorium or syncline and anticline. Yeah, this is the folded Cretaceous red sandstone that also produce some high purity quartz in the beach. This is the Cretaceous arenite sandstone, yeah, for high purity sand deposit in the Rio Islands. So the high purity quartz is produced by the weathering the red sandstone of Cretaceous. Yeah, most of the Cretaceous red sandstone is very folded, and also the folding is here. So like this is the syncline of the red sandstone. Yeah, this is the folded Cretaceous arenite sandstone of the Rio Island. Some is folded for forming syncline, and the other is forming anticline. Yeah, this is the folded Cretaceous arenite sandstone also. Yeah, that saw by drone. Yeah, by drone. This is the some of the outcrop near the beach. Yeah, that can be measured very vertically, very steep deep. Yeah. So this is strongly folded red Cretaceous sandstone of the Rio Island. And the other sand is high purity sand is come from the granite, yeah, from the Singkap area. This is the Singkap area that also produce some high purity silica from granite, from weathering of granite. Yeah, the Singkap area. Yeah, this is a high purity sands with very white, yeah, white sand or in the Singkap area. Some of the sands is weathering produced from metamorphic rocks and also granite rocks. So we can use also some tourism site here, because it's the sea is very beautiful. It also white sand is very white in the Singkap area. Maybe we can have also kite surfing, windsurfing, also maybe kite buggy, and also maybe used for the alternative energy, for example the wind energy, because at the Singkap area is very the wind speed is little bit big. Yeah, it's also high velocity of wind energy, and also the current in the area maybe can be used for the tidal energy. So maybe also we can also seafood, yeah, seafood industry in the islands. So this is the sand, yeah, quartz sand from granite in the Selayar, yeah, in the Selayar area. We have also here some outcrop of granite that maybe can use for the building, yeah, maybe use also for the dimension stone, yeah. This is the granite is very big, yeah. The fracture is very wide. The spacing is very wide. That can be used, can be mined the granite in a very big block. This is also granite using bearing uranium that can be found in the northern Sumatra, and in the eastern part of Sumatra we can also find some sand deposit that rich with the heavy mineral and tin. Yeah, this is some uranium bearing granite in North Sumatra. Yeah, this is my research in middle 90. This is the, yeah.
Time is 5 minutes left.
Okay, sip. So this is the granite that maybe have some biotite and muscovite that also rich with the accessories. Yeah, this is the accessories that we can see in the petrographic image. Yeah, we have here, for example, biotite that may be with a lot of inclusion of radioactive minerals. So the radioactive mineral we can see here, for example, the zircon that with inclusion of uraninite, yeah, also allanite, yeah, with can you see also the monazite that rich in the uranium and thorium. So the marine exploration in middle 2003, we have also here with the Barunajaya 4 from BPPT that our expedition for the submarine hydrothermal. So in this picture we can see the dredging from the Flores Sea, and we have here some indication for the sulfide that associated with the submarine hydrothermal. So we use also the Van-Veen graph, yeah, for the sampling the seabed sand, for example, sand or maybe the sediment, yeah. So we use also the CTD method for conductivity, temperature, and depth for the exploring the hydrothermal undersea water. So we have also exploring the tectonic, yeah, between Sumatra and or maybe in the Andaman Sea that maybe have some maybe we have some maybe we can use for the mitigation of the earthquake. Yeah, I think the challenge for marine mineral exploration and energy is very wide in Indonesia. Yeah, we can use, for example, how the hydrothermalism maybe in the western part of Sumatra, yeah, associated with the trends. Yeah, maybe in the trends we can show also the hydrate gas, yeah, in a deep of 4,000 meter. Yeah. Also, we can use also, for example, the gas hydrate in the prisma accretion in the southern of Java. And also we can also searching for the mineral, yeah, for example the heavy mineral in the Lesser Sunda Island, for example the Flores, Sumba, yeah. And also we can use also some the hydrothermal active, yeah, maybe we can find also hydrothermal active between Sumatra and Kalimantan. And also we have also opportunity to the exploring the hydrothermal active area in Banda Arc. So thank you very much. for this presentation.
Thank you, Pak Andri, for your comprehensive presentation. Ladies and gentlemen, so now we are approaching to the last session for discussion or comment regarding to raise the topics from 3 speakers. So please, if you have question or comment, to raise your hand and open your microphone. Otherwise, you also can write down the question or comment in the chat box. Any question, please? Okay. Now, meanwhile, we are waiting for the question or comment. So here we have 2 questions in the chat box, but they are already answered, I think. So for Pak Ahmad Januar or Pak Johannes, if you still have more additional explanation or additional question, please to open your mic. Okay, Pak Johansson is thank you. Okay, no problem. Okay, so,
I have
yes.
an additional question for Mr.
Please,
Dr.
please.
Kim. Yes. Thank you for the previous answer, Mr. Dr. Kim. But I would
Yes.
like to just clarify something about my question. So I can classify the earthquake based on the focal depth, or should I do something else to classify the earthquake as a deep background source or shallow crustal fault source? So the question, I'm sorry. So basically the question is, should I do something else to classify the earthquake to separate it from a deep background source with a shallow crustal source, just based on the focal depth, or what?
Yes. Okay. Thank you for your interest. I think, as I told you before, the focal depth is 16 kilometers, and that is the extremely lower part of the brittle upper crust, or approximately at the upper and lower crustal boundary. And some scientists in Korea suggested that the whole area of the Korean Peninsula and its continental margin was deformed relatively highly due to by the occurrence of the 2011 Northeast Japan Great Earthquake with magnitude of 9. Yes, and at that time, the whole crust around the Korean Peninsula was moved to the trench side to the east, and then it tried to regain its position. I think the crust came back to its original position. But as you know, the brittle upper part moved very quickly, but the ductile lower part is slow in moving. So that means the stress was generated at the upper and lower crustal boundary. And I think that caused the earthquake.
Okay. So basically the earthquake is caused by the residual effect of the subduction that caused the 2011 Tohoku earthquake.
Yes, Tohoku.
Okay, so it's not from
that occurred in the forearc region, but our earthquake occurred in the back side.
I see. Okay.
Yeah,
Thank you for the
yes, and the additional comment is that the Korean continental margin is much it's not. It does not belong to the Benioff zone under the sloping subducting plate. It is quite far from the subduction. So it is not directly related to subduction, but indirectly related to subduction, I think.
I see. Thank you for the answer, Dr. Kim.
Thank you for your interest.
Thank you, Mr. Ahmad and Dr. Kim. Any other question or comment?
Maybe can I ask Mr.
Yes.
Hansan?
Please, who is it?
Hello,
Yes, please, sir.
Andri.
Pak Andri?
Yeah.
So, please, Pak Andri.
Hello, good afternoon, Mr. Hansan. So I asked that the equipment in the research vessel of the Korean that is very nice, because with the complete equipment the ship is small. Yeah, we have, for example, the Barunajaya 8. This is very big ship. Yeah, but is that the small ship of the Korean have also the reflection seismic? Reflection seismic equipment. Yeah. Yes.
Yep. Thank you for question. Yeah. So you ask what kind of a seismic?
Multi-channel seismic.
Multi-channel seismic. Actually, not. I'm not expert about the seismic. Survey. But we only have a SPP model. I already explained it in my presentation. So is it appropriate for your purpose or not? Yeah, I'm sorry. Yeah.
Yeah. Okay.
Okay,
Yeah.
Dr. Park, can I answer the question?
Yeah. Thank you.
Okay. In our institute, we have lots of facilities for multi-channel seismic surveys, but in the Indonesian center, they have only one single channel acoustic profiler.
Yeah. Okay. Maybe the for example, for the hydrothermal, is that the research vessel is also equipped with the opportunity to searching the small volcano or small hydrothermal tower or small hydrothermal chimney? Is that in the Korean vessel? They have, is that?
So to find out the submarine volcano. Yeah. So actually that is depends on the way. I mean the equipment for seismic sensor maybe. So actually I cannot understand your
Maybe
question.
probably about the resolution, Pak Hansan, because as Pak Andri explained, so some target usually small. For example, the channel in submarine channels probably not so wide. So it's mean we need more detailed image for the subsurface. Is it how the MTCRC has the equipment dealing with this necessary for the high resolution imaging of the bathymetry?
Yes, actually our equipment just fit to shallow water. I mean 100-meter sea depth, water depth. So within 100 meter, our equipment has very high resolution rated with a beamforming mercury echo sounder. So I think if Sunda Sea there is some kind of the channel or some volcano something, maybe our multi-beam echo sounder can detect that some changes of topography or under the sea, so we can find it. But maybe we need also some kind of seismic sensors needed to confirm that the shape of a channel or a volcano.
Thank you, Andri.
I think very interesting because, for example, the Sunda Shelf have a lot of paleo river, and then how can we detect the paleo river if we have maybe the seismic equipment? Yeah, maybe it's simple. We have used also, for example, the single channel seismic for depth maybe until 100 meters. this is interesting because Korean have also research vessel that can maybe until 100 meter the detailed topology by what is seismic, yeah, single channel seismic in the research vessel.
Oh yeah, we also want to try to find that kind of parallel topography, and then actually I would like to ask to Mr. Dr. Kim Hanjun about that matter. We only have multiple echo sounder, where those geosource 4R, and then only have a SPP. So is it enough to find out that kind of parallel river or volcano topography on the sea?
And as an additional comment, my experience, from my experience, I can tell that to identify and locate parallel rivers, I think you need at least the Sparkle seismic survey system. The single channel SPP sub-bottom profiler is very weak to generate strong pulses of seismic energy.
Okay. Thank you.
And I assume that the sedimentation rate is quite high around Indonesia and Sunda Shelf.
Yes.
So you must see the deeper part of the sedimentary structure, and you should use at least the Sparkle source type.
Okay.
Yes. So I also have that worries to use our equipment to survey that. SPP has only 40 or 80 meters penetrated depth. So maybe a parallel river has more sedimented depth. So as a recommendation from Dr. Kim, we need some more equipment kind of sparkle.
Mr. Hansan, maybe I ask only one question more. Is that the research vessel from Korean has also to take sample from seabed, for example, sand in the depth maybe from 50 meter until 100 meter. Is that equipped with the sand sampling in the seabed?
You have a grab sampler. That is very usual model, and we operate it with the winch. So depths of 100 meter will be applied at the grab sampler, but we did not yet try it.
Okay. Thank you.
Okay, so maybe this is one chance to try the grab sampling, Pak Andri. Thank you, Pak Andri, Pak Hansan, and also Pak Kim. So here I see also Professor Safwan Hadi attending this seminar. Professor, if you have a comment or question for us, please don't hesitate to open your microphone.
Okay, thank you, Pak Asep. I just want to give my comment or remark. Since MTCRC has a lot of equipment for marine geology survey and marine geophysics survey, I think it's better for us to make joint research together between Department of Geology of ITB and MTCRC using the equipment that MTCRC has. So maybe you have expertise in geology at ITB, but we in oceanography using the MTCRC equipment can make a joint research together, and also we can collaborate with a Korean scientist from Kios to study sediment in Java Sea, in Riau Island, and other island of Indonesia. I heard that our government will do again the sand mining that can be used for developing highway and other purposes. So we don't know how much is our resource in sand along the coastal zone of Indonesia. How deep is the depth of the sand, and how much we can mine it for purpose in construction, for example. So this is a chance for us together to study the sediment that lies in the coastal area of Indonesia. We have equipment and we have expertise in geology, in chaos. We can do it together.
Yes. Yes.
Pak Hansan will be happy to work with a colleague in geology department.
Yes.
So maybe Pak Hansan can invite our colleague from geology department of ITB to come to Cirebon to see the facilities there and just try a ride with our boat and along the Cirebon coastal area, just to feel how we can put together, study the sediment resources in coastal area of Indonesia. So maybe Pak Hansan will invite our colleague from geology department of the ITB come to Cirebon and see what topic of research we can create together that can be published in the international journal that will benefit for ITB and also for MTRC and also for KIOS. So this is the same for us. Let's go together. Let's try to cooperate in studying the geology of Indonesian seas, especially in coastal area. That's my comment, Pak Asep and Pak Hansan and Dr. Kim.
That is very great comment, Professor Safwan. So we hope together we could make it's possible, because usually geology is dealing with ground. So now we are moving to the ocean. So we need equipment actually. So before that, we have still 5 minutes. Thank you, Professor. Pak Hansan or Pak Kim or Pak Andri, if there is any comment according to the Pak Sofwan comment, please.
Yep, I have to answer his comment. Actually, we are waiting for cooperate with the other department and also the other university with the MTCIC. So we will be very welcome when you have time, and we can make a schedule to visit the Cirebon Center, and then we can try next very meaningful survey together. And then very thank you for that Professor Pan's comment. And then I would like to ask comment from co-director, Indonesia co-director of MTCIC, Ibu Ibon. Ibu Ibon. Maybe is another important theater. Yep. Okay, that's all from me. Thank you.
Thank you, Pak Hansan. I see here also Bu Ipon or Pak Prihadi. Pak Prihadi from Geological Department. So he is expert in geophysicists actually. So Pak Prihadi sometimes build his own equipment or in geophysics. So maybe Pak Prihadi has a comment. Probably we could attach our equipment or your equipment in the Arabut for the future research, probably. Pak Prihadi, are you there? Okay. Or maybe he's busy. Or Ibu Ivon, probably. Any comment? or anybody? So we have still a couple minutes. If you have comment or question regarding our discussion today, it's very welcome. Mr. Johannes, please. Yes.
I have some additional questions to Pak Hansan, but I'm afraid if my question have no correlation about regarding to our topics right now. But anyway, I've just checked your link that you've been shared in the chat box, and I'm quite interested about what you've been done in operational oceanography forecasting system. And you mentioned here that the MTCRC were using ROMS to correlate the simulation with the atmosphere data from the satellite. Would you like to tell us, or maybe explain a little bit about this research? I'm quite interested. How do you do the correlation between the atmosphere data from satellite and your field data, and how long it takes from the training the model until you can make the simulation? Thank you.
Yep. Thank you for question. Actually, that is related with the numerical modeling for operational ocean forecasting system. Actually, MTCRC already established Indonesia side numerical model for Indonesia Sea. 4 years before, and then we are now on operating that in our numerical model server, and we are planning to improve the correction, the accuracy and the resolution of that model. So actually, I cannot answer your question exactly. I mean about atmosphere data and correcting with our model result, because I'm not modeler. But if you have, I can answer about your question through email, to contact the Korean researchers. And I want to emphasize that numerical model is now on developing, but on operating actually. So every day we produce 72 hours predicted, forecasted the data, including wave and tide and current and also weather, wind or something, right? But we need more in situ surveyed observation data to increase the accuracy of our model. That is also our challenge to MTCRC and also with the Indonesian researchers and government. Thank you.
Okay, Pak Johannes. Do you have more comment, Pak Johannes?
No, Pak Asep, it's enough for me.
Enough. Okay. Okay, everyone. So time is over. Thank you again for your patience and also for your time attending to this seminar. Thank you, Dr. Mirzam Abdurrahman, Dr. Hansan Park, Dr. Kim Hanjun, Dr. Andri Slamet Subandrio, and also Professor Sofwan for a very nice opportunity or a very nice comment regarding our future collaboration research under the ocean floor. Thank you again, everyone. So I close this seminar. We hope we see again in the next near future seminar. Thank you and assalamualaikum warahmatullahi wabarakatuh.
Thank you.
Thank you. 감사합니다.
네, 감사합니다.
감사합니다.
See you again.
Terima kasih.
See you again. I hope to see you again.
See you again, everybody.
Thank you, Professor Pan. Thank you, Pak Asep.
Thank you.